Okay, in a second here, I will get started. Let's just wait for the stream to come up. And I'll just need to post a link to it. In a second, I will get started. Okay, let me start my music. Okay, cool, let's get started. So, what am I wanting to do today? Today, I'm going to continue working on particularly the data tracing functionality within the Ghidra static bug finder. Purpose of that being is, let's say the static bug finder right now, it can flag a function, say it has the potential to be a bug, such as like, let's say there's a mem copy and the size is variable. However, what I'm trying to do with the data tracing functionality is get a bit more introspection into like what the context is behind that. Like, let's say the size. Okay, the size is a variable. Is a size ran through any sort of checks? The destination pointer, where is that coming from? Are there multiple paths? If so, where are they all coming from? Is it just you grabbed from a struct? Is it from malloc? Is it from the stack? And the purpose, so by implementing data tracing, I can hopefully get more context as to like the conditions behind the destination, the size, and the source. And using that context, I can better estimate if this is more likely to be a bug or less likely to be a bug. So with this, let's continue. I believe where I left off from yesterday was... Okay, yeah, now I remember. Effectively, I was trying to, so how I'm doing this since I'm iterating through the P codes is I'm not iterating. Normally what I was doing beforehand, I just got an iterator, I just iterated next, 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 next. However, an issue with that is, that there are conditional branches. Also, hello, new people that just joined. Feel free to ask questions. Yeah. So, yeah, issue with just doing that previous way is that there are branches, there's P codes that will say, hey, the next P code to be executed is not the one immediately following this. So I switched over to just iterating by an index. That way, if I get to a P code that says like, hey, next P code to be executed is a one way over in another part of the code path, I can just directly jump to it. Now, where does that... Now, for that, part of what I need to do is when I get to a branch P code, I need to recognize that, hey, well, first that is a branch, and then what's the address, and actually get the P code associated with the address. So, yeah, that's what I'm trying to do right now, is from an address, get what the corresponding P code is for that. Okay, cool. So for this, let's go ahead. Let's go into... I'm going to just first get a static analyzer running. Yeah, fgets5 is the one I'm interested in, right? Let me just double check it. Basic fgets. What is the source code for this one? Okay, yeah, like an instance for here, the input pointer can be set to either a malloc chunk or a stack buffer. This is an instance where this type of iterating through a function will provide valuable context. Because with how I was doing beforehand, I would just look and see, hey, we can see that a pointer that is stored on the stack is an input, but where this pointer is pointing to, so where the data is actually going to be stored, it has no clue. Cool. So moving through here, let me guess. Oh yeah, it needs to be process, not import. Okay, so the question is, yeah, C branch. Actually, let's let this run. Excuse me. Yeah. Let me go ahead and just verify that it can get the actual branch address. Plus branch address. Okay, yeah, it is, because this is the branch instruction, and this in hex is 1011FA, 1011FA. Okay, cool. Yep, that is the correct address. Now we need to actually correspond that with a, what do you call it? A P code. Now, my initial plan for how I was going to do this was I was going to have a hash map where the key was a P code and the value was an index, and populate it right here. And then what I could do from there is just take the address, get the P codes associated with that address, get the first P code, and then just look it up in the hash map to get the index. However, it does not appear like, well, it appears that the P codes generated for some reason are maybe a little bit different, or for some reason the hashing function isn't working 100%. I'm not sure. Point being, that method isn't working, so I'll have to find a new one. Now, how will I do that is the question. To start off, I'm going to look at the P code Java docs for Ghidra and see if there are any Ghidra P code Java. Okay, let's see. What functions do we have to work with? We have, no, this returns an iterator to the P code. That isn't what we want. Get input. No, that's not going to help us. Get mnemonic. Get num inputs. No, not going to help us. Get opcode. Not going to help us. Get output. Not going to help us. Get parent. P code basic block. I don't think that's going to help us. But maybe. Get iterator. No, I don't think it's going to help us. Get sequence number. Initially, when I saw get sequence number, I thought sequence number would be like the index, effectively exactly what I'm looking for. But when I looked at it further and tried to use it, I think it's the index number for the actual basic block, not the function. So it's not really going to help us too much. At least how I'm imagining it right now. What is next? Read XML, remove inputs, set inputs, opcode, set order, set output, set time.toString. Clone equal finalize. These are all from object. That's not going to help us. Yeah, this isn't going to help us. So nothing in the P code op Java class. I don't see anything that's going to help us. I'm going to try looking at the high function Ghidra class. So let's look through here. Let's see. Get function prototypes, get jump table, get language, get local symbol map, get map simple, get symbol, grab from function. No, that's not gonna help us. New var, no. Let's look through here. Find varnode, find input, no. Get num varnodes, get P code up. Actually, I wonder. Looking at here, I'm just going to iterate through all of the, because there might be something weird that's happening. I'm just going to iterate through all of the keys for the hash map here just to verify that the P codes that I do expect to be in there are indeed in there. So I'm just going to Google how to Java iterate through all keys of hash map. Okay, so we can do something like this for P code up, P code in mapping dot key set. Go ahead and print system dot print line, iterate P code. And let's go ahead and print out the first P code. This should tell us if iteration prints nothing this line right here, then it's an issue with how we're populating the hash map. But let's see what output it gives us. So we can see the P code that it jumps to is this right here, which, let's see. Not theirs. Where is Z extend? Which, no, it's not there. Wait a second. Call. Is it here? Hang on a second. We can easily see this with just a simple Control F. CEXT. Yeah, okay, cool. So we see this P code right here from the hash set is basically the same as this P code here. So for some reason, this P code and this P code are not equivalent. Probably deals with some like the internal Ghidra Java API shenanigans. Point being, okay, yeah, that method 100% is going to work. I verified that it wasn't like some stupid mistake that I was making where the hash map wasn't actually being populated correctly. So where does that leave us? That leaves us, we need to still find out another method. It'd be so nice if P codes could, is there a way that we can? Yeah, it would be nice if P codes kept track of what address they were tied to. But maybe P code op AST. Let's take a look at P code op AST. Get basic iterator and get parent. What just got get parent do? Contain no. Oh, okay, this is gonna take me a little bit to figure out how to do this. So, think how could you do this? So I'm gonna spend a minute here thinking. What's the issue? The issue is I have an address. I need to get the corresponding P code for it. I can get P codes associated with a particular address. However, I'm iterating based upon P code. Or do I even need to do that? Welcome new person that just joined. Ask in the chat if you have any questions. Might be better just to go back to the beginning of the stream and keep watching from there since some work has been done since then. Now, what was I thinking? Right now, I'm iterating based upon an index. However, now that I think about it, I can get the first P code associated with an address. And I could I just iterate through using a normal iterator, and then when I get a branch instruction, I just take the P code from there and just set that to the current one? No, because then for the next one I'll just have, well, I could have, no, yeah, that wouldn't work because the iterator wouldn't get its position updated from what I understand. This is going to be fun to deal with. Now, how can I solve this problem? If only I could store an if only, yeah, I need to have an address, need a P code. How can I do that? You know what? Can I do that? No, can't. Let's take another look at the P code op Java page. Maybe we're missing something. Get out returns a varnode. You know what is the sequence number? Does this have anything useful to us? Get order, get relative position of P code ops within a basic block. That doesn't help us. Create a new sequence, set order to set time, set unique sub address registering. Don't know what that does. Dot equals. Don't think those. Well, wait. Compared to. There's a compare to sequence number. Could we, by chance, this compare to method might be what we need. Let's try this. I'll need to change this from P code op to sequence number. Let's see, sequence, yeah, that's correct. So my idea here is basically, I'm assuming that this compare to will effectively just, we give it one sequence number, well, we effectively just check is sequence number X equal to sequence number Y, and we can just use that to compare the P codes. Might not work, it might. Let's see. Actually, not exactly what I'm going to do, but let's just try using sequence numbers instead of P codes. Resolve. Oh, wait, no, this is what I need. Change this to a sequence number. Get sequence number. And from here, you all need to also change this. There's probably something else that I'm missing, but I will find that out when I try to run this. Get sequence number. Okay, let's try running this. Class not found. Okay, I made a mistake somewhere. Resolve index. Okay, let's try debugging this. get rid of resolve index first. Oh, this needs to be sequence number. And I'm just going to comment out this function right here just to verify that the problems that we are debugging are not there. Sequence number cannot find symbol, which means I need to import it. What is the... Okay, let's import this. Okay, let's see, does this run? Does it run? Cannot be converted to... Okay, something. Oh, this needs to be changed to sequence number. Yeah, I was pretty sure there's some things I was missing that would cause an issue. Okay, this is working. Let's try this function now. Okay, it ran and appears to have given us 13. Might be the one we're looking for, I'm unsure. Let's see. How we can see that via adding a print statement here. Print line I plus I should be the index associated with a particular P code. This will print out all of the P codes and their associated index. Don't need this print statement. Let's get rid of it. Don't need these print statements. And you can add a result plus. Okay, let's try running this and see if it gives us the value we need. Okay, we can see that index 13 is the int z extend, which is the P code that we're looking for, and that is indeed the index that we were able to resolve to. So cool, we were able to do pretty much exactly what my initial plan was, except we had to use sequence numbers instead of P codes for some reason. I'm guessing it has to deal with like the internal workings of like a Ghidra with how they model stuff. Probably, if I had to guess, whenever we call the what is a function? Get P code ops, I'm guessing that it probably generates like either like new models or just new P codes which model the same thing, but since they're different objects, when you try to hash them in the hash map, it results to different place or spots in the hash map. Cool. I had a bit too much coffee, so I'm just going to take a second and just go to the bathroom, BRB. Okay, I'm back. Now, okay, cool. So we can effectively resolve a. We can take an address and get the corresponding P code for that address. That is good. Or the index associated with that. Now the next question is how are we going to actually adapt our model to it? For branch instructions, we can just set. Okay, we can do something like this where we get int. Actually, let's switch it over to small int. Int new index equals resolve index. So for branch instructions, we can just do that. However, for C branch instructions, we will have to, since it branches two different ways, we will actually have to analysis branch two separate ways. However, before that, there is one problem that we're going to have to deal with, and it's the fact that for while loops, we might enter into an infinite loop, or let's say you have a conditional, and the conditional is either if this condition is true, jump back to the beginning of the loop. If it isn't true, then it can exit the loop. However, if we're continually forking with conditionals down both paths, one of those paths will just continually just keep going to the start of the loop. So we need to have a mechanism in place to effectively account for that. Also, welcome new people. If you just hopped in here, probably gonna be super confused. I'd recommend going back to like the start of the stream if you want, or you can just keep watching this, do whatever you want. Okay, getting back to this. So we're going to need to have a mechanism in place to keep track of which indexes we've looked at. Because in the case, we do reach those things where we reach like a while loop, and one of those paths jumps back to code that we have already looked or analyzed, we won't enter into an infinite loop. Now for this, I'm going to have a hash set. It's going to be int integer scene indices. And my current idea for how I'm going to tackle this is, well, first I'm going to tackle the detection of if we're entering into a potential infinite loop, or we're just looking at P codes we've already looked at by just having a hash set that keeps track of the indices we've already looked at. So we can just do if scene indices dot contains I. This code right here will deal with how do I want to call this? P code reanalysis. Not sure how I want to deal. Basically, looking at the same P code we've already looked at beforehand. Unsure of how I want to deal with that for now, so I'm just gonna slightly put that to the back burner for a second. Now, we can also just add, let's see, I to the hash set, and that will allow us to effectively detect if we've looked at a hash or looked at a particular index multiple times. Okay, cool, so that runs just fine. So we've reached an index which we've already looked at. How do I want to deal with this? Well, what are the instances in which we would already have looked at? I'm thinking. So this is what I'm currently thinking. What we're probably going to have to do is we're probably going to have to offload the actual like iterating through the P codes to a recursive function. Why, or some sort of like recursive function. Why recursive function? That way, when you reach a conditional branch, we can just make two calls to the two different code paths that they fork, and that way you can effectively, with our analysis, analyze along how the code paths actually split. That way, if let's say we were to analyze along a code path at which, yeah, if we were to analyze along a code path that hits only a certain checks in a certain order, we would see it that way from our analysis. So what I'm thinking about doing is each time it splits, or each time a new like fork goes off with our analysis, it keeps track of its own separate indexes that it's seen. And effectively, if it does see, hey, I'm going backwards, or I'm looking at stuff I've already seen, we can just kill that analysis fork right there. So, okay, I'm probably just mumbling a lot right now. Yeah, I think that's probably the best way. So, in order to do that, I will need to offload this to a recursive function first, and then go from there. So, let's do that. I'm going to copy this over to another tab, that way I can reference the code here when I'm making that new function, because it's going to be extremely similar. Let's copy that over there, and then move this over here. Cool. So we're gonna want, I'm just gonna call this public void iterate analysis. Probably gonna come up with a better name for now. This is just what I'm currently thinking of. And for this, so this check will effectively set this up. What do we need here to iterate? We will need the hash set of scene indexes. We will need the P codes, of course. P codes. What else will we need? We will need a separate data structure to model the varnodes as they go across, maybe something else. However, for now, I think we can effectively table that for later. So, okay, moving on from here. What's this? Of course, we're going to need to have this for loop. Just copy that. And then we can have this code right here to deal with branches. A new index. Oh, of course, we will need to have this code right here to deal with instances where this particular analysis thread or analysis fork reaches code that we're already analyzed. So we can just go ahead and return from there. Okay. And next we will need to have code in here. So what do we want this function to do? We want this function to effectively iterate through the P codes in the same way that the code will do until it hits a particular function call. And then it will return to the check with probably some sort of like data structure or something that models, hey, this is the context that we were able to get from the analysis. So it's going to need to recognize the actual function call, and for that, we see here it will need this code right here, current P code. What is call? Where's call site coming from? Varnode. Oh, it will need both of these. So what do these checks do? Checks if it's a call P code, verifies that the first it's just a sanity check, verify that the first argument is an address, which it should be. Checks that the address being called is the one equivalent to the function. Now we will need the actual function with this. Function func to analyze. And we need anything else. Current P code. Oh yeah, we will need to set the current P code. P code op current P code. Current P code equals P codes of I. Let's make sure that this runs. Cannot find symbol. Resolve index line 746. Resolve index. P code mappings. Oh yeah, we're also going to need the P code mappings and the calling func. Could switch this to just the reference, but first let's deal with this, which is what we need. P code mappings. Okay, that's that. Next we need the calling func, which we get from the reference. So I can also just put the function calling func. Just throw that here. This function argument list is getting rather long. Let's go ahead and run this. Okay, so it works just fine. Cool. So next thing that I want to do is look at how it's actually, what's the right term? Well, no, don't want to look at how it's iterating through the P codes yet. Next, what I'm going to need to do is make the recursive calls for the conditional, which I'll do here. Okay, actually, looking at it, I've been streaming for about 40 minutes now, so I'm going to go ahead and call it a night for streaming. Thank you for watching and see you next.